Good evening, everyone. So welcome to the last session of the day. We hope to get you out of here in time for your cocktails and drinks. If you can keep your questions to the end, then we have a few things we want to cover here in terms of our security picture for Spark. So my co-presenter, Vinay, is right here, and I will be walking you through some approaches we have for Spark security. Let's go here. All right, so my name is Shrikant Venkat. I run security and governance for Hortonworks products, Apache Ranger, Knox, Atlas, and platform security. And Vinay Shukla, who's my co-presenter here, runs data science from a product management perspective. So we wanted to take this time and kind of share some perspectives on how in the Hadoop ecosystem we can secure Spark and beyond, and then what are some of the approaches that are emerging in this area. So with that preamble, let's look at this. So this is a graphic that we use in order to explain the different layers of security. So this is slightly different from those of you who were at my cloud talk earlier today. It's a slightly different picture here because we have a few more things to take care of. Security always comes in layers. So you start from the exterior, from your moat or the network segmentation of firewalls at the end, and then all the way in via the drawbridge that you see here in the front, and your guards checking your identity, which is LDAP, AD, Kerberos, etc. The drawbridge that you see is Apache Knox, which is our secure gateway as part of the HTTP ecosystem that gives you the ability to authorize APIs as well as proxy UIs, and also provides SSO capabilities across the platform. Then you have your Spark and Hadoop that you want to secure. And all around this, the perimeter, you have these watchtowers, which are Apache Ranger, and your HDFS ACLs as well as Yarn ACLs, which give you the right authorization models. And in addition, Apache Ranger also gives you the audits, so you know exactly who touched what and when via the Spark jobs if you're going through certain paths. And the foundational underpinning of being able to not jump over the walls of this castle is your encryption. So that is your data at rest protection. That's HDFS encryption that you see on the bottom right there. And then the service-to-service communication is the inner walls. The hard walls there would be all wire encryption. So this is your SSL, et cetera, that you can use to secure. So this is our sort of our 10,000-foot view of what we think of security as it pertains to Spark and Hadoop in this ecosystem. So what are some of the challenges that we see? So the challenges are pretty similar to what you will see with other big data deployments or other, even traditional database and other types of environments, which is the primary key use case is around AAA or authentication, authorization, and audits. You want to get all of those three areas addressed adequately in any of these settings, and Spark is no exception. And then you want to secure from the network across the perimeter and also protect the data both in motion and at rest. So these tenets are pretty much foundational and they stretch across those. So Spark is no exception. So we want to be able to cover these with the security stack that we have in the HTTP platform. Again, the overarching theme here is to make this as easy to deploy, manage, and administer and govern over time. So what are some guiding principles here? Let's take a look at a few of those. So if you remember the castle picture, we want to start outside in. The first thing you want to do is to be able to secure the network, which means firewalls, secure gateways, whatever else, as you're getting into this, getting requests into your data lake and being able to authorize and authenticate those users as they try to access different services that are running or different computes that are trying to access the data that's sitting in your HDFS clusters. The second principle here is only primarily providing around authorization envelope, which is using LDAP and AD, Kerberos. Kerberos is being the strongest for method that we have currently for mutual authentication across services, and service level authorization, which is provided by Apache Knox, so you could authorize which users can authorize which services, Spark being one of them. And then the other tenet here is around developing authorizations at the fine-grained and coarse-grained level. So you want to be able to authorize at, say, for example, at the data at the source itself, whether it's sitting in Hive or Hbase or HDFS, and Apache Ranger, which is the comprehensive security console that provides authorizations across the platform, can be used for this purpose. And you protect the data where it's resting, and you also protect via the compute so that you can have the right authorization policies built for the right context in this case. Ranger provides what is called ABAC, or attribute-based access control for authorizations, which gives you a very precise way to go to a particular resource, which could be a file or a database or a column sitting in HDFS, and write the right authorization so that whenever any Spark job tries to read that through different channels, you'll be able to provide the authorization filters around that, so the right users get access to it in the right context. Last but not least is data protection. So that's two things out there. So that's TDE, transparent data encryption, that is transparent to the application, and wire encryption, which is data in motion and SSL. So those are some of the guiding principles. And then I will hand it over to Vinay, who will cover the details of how that works in the Spark context.
Hi, everyone. How are you guys doing? Well, it's not that kind of talk. So it's the end of the day. Let's make it a little bit fun. So if you have any feedback on the talk, I'll appreciate if you can go to the app, give us some rating so they invite us next time over. So now let's look at Spark and security. So as you know, Spark is, depending on who you talk to, Spark is like an elephant. A lot of people describe Spark in a different way. I describe it, if you literally just translate the language of Spark's description from the Spark website, it is what it says it is, which is in-memory data processing system. That means it doesn't store data in itself. It doesn't say data storage and processing. It's only data processing. In-memory, meaning it has to read data from somewhere else. So all the security relies on data being stored somewhere. That means that somewhere, you have to tell that somewhere who you are, so it can apply the authorization policy on that. So as Shrikant mentioned, security has 3 or 4 pillars. The most are actually 4 pillars, but the biggest, the first 3 pillars are AAA: authentication, authorization, and audit. And they are actually in serial order. Like authentication is step 1. Without authentication, the next 2 steps don't mean anything. So it's exactly, so I'll try to explain all the security principle and apply that to Spark. So there are many ways to interact with Spark. If you are in my previous talk today, sorry, you're seeing the slide twice today. So there are many ways to interact with Spark. Let's say you're setting up a BI tool like Tableau. So that Tableau tool speaks ODBC, JDBC. So you can connect that Tableau tool to Spark Thrift Server, which is a listener for JDBC, ODBC, and that you can make that connection. If you just downloaded Spark from Spark website and you're writing your first Spark app, typically you're invoking the Spark REPL, which is a Spark shell at the bottom of the slide there. If you have moved beyond that, if you're using Notebook, and in this slide I have an example of Zeppelin, but let's say you're using Jupyter, and in that case you can replace Zeppelin with Jupyter in that diagram in your mental image. But if you're interacting with Spark via Notebook, you are using a remote connection to the Spark. So Zeppelin would be your path to invoking Spark via a remote notebook. You can also invoke Spark through a REST-based API, and that's the Livy example. Another way of invoking Spark is Spark Job Server. A third way is the IBM kernel, Spark kernel. So all those are examples of REST API that is accessing Spark. In all those examples, I have embedded the orange small box in there that represents Spark driver. If you have written a Spark program wherever you said a Spark context or a Spark session, that launches a Spark driver. So that is what is represented over there. So I've tried to give you a flavor of how Spark can be deployed in production, and depending on which path you come through, if you imagine the castle analogy in your mind, depending on which door you come through, each door has to be secured, and there are implications of all that. So let's, with that context, continue diving in. So Spark can be deployed in 4 different cluster deployment mode. The rest of the talk, we are focused on Spark on Yarn. And But because for completeness, the 4 deployment mode for Spark are Spark standalone, Spark in a pseudo deployment mode, Spark on Mesos, and Spark on Yarn. Within Spark on Yarn also, there is, so to speak, 2 sub-mode. So think of it as like 1A and 1B of Spark deployment mode on Yarn. And the difference between these 2 modes is the location of the Spark driver, whether the driver is within the Yarn cluster or the driver is launched outside of the Yarn cluster. If the driver is launched within the Yarn cluster, that is called the Yarn cluster mode. And if the driver is launched outside of Spark or outside of Yarn, then it's called Yarn client mode. Why would you choose one versus the other mode? And why is it important? Good question. So if you're typically, let's say the way people start to put their application in production, on day 1, you downloaded Spark and you're playing with Spark on your laptop. On day 7, you're like, okay, I've written my good first app. I want to deploy on my Yarn cluster if you have a Yarn cluster deployed. You should choose Yarn client mode. Why? Because it gives you the logs on your console. So you're still debugging, you're deploying it, but I'm sure you'll run into some issues. So you want to see logs quickly. So that's why you'll choose Yarn client, because the logs will be visible on your console. Then once you have gone past that stage and you're out of errors there, you want to now deploy that job into a production stage. At that time, you will choose Yarn cluster mode. So now the logs are not coming to the console. The logs will go to the Yarn logs. However, in return, the return of that, the benefit of that approach is that if your client or the Spark driver dies, and you may have seen Spark driver dying if you have written enough Spark app, if it dies, Yarn will launch the Yarn, the driver or the Spark application master again. And that, how many times it can relaunch upon sort of failure, it's a configuration setting. By default, it launches up to 2 times. And that's why in production, you will choose the Yarn cluster mode for more resiliency. But you make the sacrifice of getting less logging in that case. I mean, the log goes within Yarn, so it doesn't disappear. It's just that it's not in your face. So now, how does Spark, let me build this slide. So what happens when you launch your Spark client or Spark job? So let's say you have written a Spark job and you're launching it via Spark shell. And you said Spark submit, and you specify the parameter. Your cluster mode is Yarn cluster mode. So the driver will contact Spark, or Spark driver will contact Yarn. And I'm describing the Yarn client mode here. So we'll contact Yarn and say, I need some resources. And the number of resources it will ask will be, or the resources it will ask will be the executor. So it depends on what you have specified on the command line. It will ask if Yarn allows that user based on the policy that's configured in Yarn. It will give that resources, and the first executor that will be launched is the special executor Spark application master, and then other executors will be launched. So that's sort of like the general flow. Now, coming back from the previous slide, if in the Yarn cluster mode, the driver is running within the Yarn itself. So in this slide, you'll see I've shown the example of with different colors. The green boxes are the executors running. Brown is, you can read the legend, and we may see in next few slides where this comes into play. Yeah, so now how does authentication work? So in many ways, the authentication, so Spark, like rest of Hadoop ecosystem, is dependent on Kerberos. So assuming you guys understand Kerberos, I'm not going to go into detail, but we can go into detail after this session if you have any questions on Kerberos. So Spark uses Kerberos for authentication, just like any other part of Hadoop ecosystem. So if you submit a job, and I'm describing a command line way of submitting a Spark job. If you're submitting a Spark job through, let's say, Livy, as an end user, somebody may not see this interaction. But if you're submitting a job from the command line, this is an interaction that will happen. You may not realize or may not care about this. So on the command line, let's say you're running in a Kerberized cluster. You will do a K init, get a key tab, and you will launch your Spark job using the Spark submit command. Under the covers, using the key tab that you have the first ticket granting ticket, the driver will, or the Kerberos library in the client side will then exchange the TGT for a service ticket, and then will contact different services. So if your job is reading from HDFS, the driver under the covers, or the Spark client under the covers, because everything is dependent on Kerberos libraries that are provided, they will use that ticket and go and find the service ticket for HDFS, or if it's trying to contact Hive or Hbase, depending on what your job is doing, it will try to get that service ticket. And if, based on the service ticket, the identity is proven downstream to the Hadoop system, or whatever is the data source. Now, the access policy that you have defined using Ranger, or if you're not using Ranger, whatever is the access policy in HDFS, that policy then can now be applied. So as we know that the authentication is the step one. Once authentication is done, access control applies. So once with Kerberos, the authentication is proven down to the service that you're trying to read from, access control can apply. So the flow of the information is all there. So I'll skip through that because we want to show you a demo that's more cool. So let's say once you have access control, so let's see how access control works. So let's say we have a user that tries to read a file. Let's say we have written a job that reads from HDFS, and the job runs on Yarn. Because of the Kerberos magic that's happening under the covers, the job, even though it's running on a distributed system, each node will have access to the real, will have a proof of the end user's identity. And based on that proof, when each executor tries to read from HDFS, HDFS will know who the user is, and then the access, whether the job is able to read that file or not, is dependent on the access control policy that's defined. And if you have Ranger, Ranger can manage that policy. In the diagram, you can replace Ranger with Sentry if you're not using the best distribution. Sorry. So now, refer back to the slide where I showed there are many different ways to access Spark. Now I'm talking about Livy. In this diagram, if you're not using Livy, if you're using IBM's Spark kernel or the Uyala job server or some other, if you have written up something like that yourself, you can substitute Livy in that diagram with whatever else. So Livy is essentially a Spark client. So if you think of it, input to Livy and output or connection between Livy and Spark. Input to Livy is HTTP, and downstream of Livy is just Livy embeds a Spark client, so it's RPC. So all Spark clients generally talk RPC. So think of Spark client or Spark Summit in that sense is very much like other Hadoop clients. They talk to the cluster using RPC. So the first connection, the first hop is over HTTP, the second hop is over RPC. Over the first hop, Livy today only supports Spinego, which is Kerberos authentication over HTTP. So that means the machine from which you are trying to access Livy, that machine has to have a Kerberos ticket at hand, and it will present that Kerberos ticket down to Livy, and then Livy can, using that Kerberos identity, can launch a job using the Spark client that's within Livy downstream. So from that, once the job once the control flow reaches Livy, there is no difference from that point. Think of it as just a Spark client. So there is a blog that was published that talks a lot more detail there. So if you're curious, you can go see that. So now, recently in Spark Thrift Server, a do as property was enabled. So what is do as? So think of, imagine John Doe or Jane Doe connecting to Spark Thrift Server, and the use case is a BI use case because Thrift Server is used in that scenario. So the user connecting to the Spark Thrift Server, user tells the Spark Thrift Server, I'm John or Jane Doe. Spark Thrift Server will not tell downstream who the connected user was. And that was true until very recently. And why the Spark Thrift Server did not tell downstream was because Spark Thrift Server did not have support for what's called do as, which is, it's coming from Java, but it's basically didn't have support for identity propagation. So that was a feature that was, or that was a bug that that feature was not implemented in Spark Thrift Server. So that feature was now implemented in Spark Thrift Server in Spark 1.6 with HTTP 2.5 and 2.6. However, this feature only gives you a coarse level, a coarse-grained authentication. So it gives you whether a user has access to a table or not. And that's not very interesting. So even though this feature is now there, I will not recommend that. The better feature is you want row and column level security, which is with Spark SQL. So you can have XYZ user. So we'll have a demo on that, so I won't explain row and column level security right here. But so even though we just implement this feature, I wouldn't recommend using it because there is a better alternate. If you can't choose that alternate, then at least this path is there. So there is a blog detailing a lot more work and a lot more details written by the actual Spark committer who has implemented that. So there is a lot more detail there. So again, there are a lot more ways to interact with Spark. Another common scenario is people will, especially with Spark streaming, people will connect Spark streaming with Kafka. That's like, if you're using Spark streaming, this is like the de facto usage pattern. So in that case, until very recently, Kafka didn't support SSL connection between Kafka and Spark receiver. So that feature was also added, and you can find more details on the blogs here. So it now works over Kerberos and with SSL. So Spark can also connect with Hbase. So for example, and this will be the use case, why would you use Hbase with Spark? So Hbase is good for IoT scenarios where data is changing very fast. You may want to build a dashboard or may want to build a sort of like analyze the quick changing data from Hbase. So in that case, you may want to connect, for example, Hbase and Spark. Let's say you're landing, as the stock market is trading, you're landing all those changing stock information in Hbase. You may want to analyze that from Spark. So in that case, you may have used Spark Hbase connector to read that data. So there is a Spark Hbase connector that's linked there. Now this also supports Kerberos space connection, so you can take advantage of that. And it's just an example of command line. So you'll have access to all these slides. So, and with that, we are down to the demo and the most important way, the best way to use Spark SQL.
Thanks, Vinay. All right, so let's maybe shift gears a bit and then talk through the latest and greatest in terms of how we see security being applied. So we talked through all the different approaches, and the one that we're going to look at is using Spark SQL via high-level LAP. High-level LAP, it was introduced in 2.5, HTTP 2.5 as a tech preview, and is generally available in 2.6. And the Spark SQL talking to high-level LAP gives you the context for all the range of policies to be applied behind the scenes. So now in this way, if you apply, if you're going to Hive directly using JDBC or using the Spark's JDBC drivers, either one of those cases, the security policies will be available at the row and the column level. So we'll see an example of how that applies. So some of the use cases here are you want to be able to explore your data lakes and democratize the data access without inhibiting your data scientists or other folks from being able to get to this data. And we already saw that Spark provides the strong authentication via Kerberos and wire encryption via SSL, but being a compute platform, it doesn't have any built-in authorization system. So this is a way for us to say, as you go to the data that you're trying to get to, let's make sure that the path that you're going through can be secured, and you can apply very fine-grained security in that model. So what this means is there is currently no way to have like a pluggable security model that has fine-grained authorization. And in the alternate, what we are doing now is to say in these different modes, how can you layer that additional security that you can expect from the other data sources and have that protection be resident with the data sources themselves in terms of how you define the security policies. So the use cases here, for example, you may want to have, you may have commingled data and you want to show different views of this to different folks. So you want to apply some level of row-level filtering, and each of these groups want to be able to see different data, even though they're running the same query on the same table, for example. The data may also have regional restrictions, so depending on where you're accessing this and which group you're part of, then you may want to see different views of the data. So that is another use case where you want to be able to see, different, apply different views into the data that exists via the processing engine surface that to users based on their context. So you may want to have, for example, certain users can see the data in the clear, certain users need to see masked versions of the data. So all of those kinds of capabilities you can now enable in a Spark context. So how does this all kind of come together? So as we mentioned, the interface to doing this via Spark SQL is through Hive LLAP. Hive LLAP is essentially a way for us to have interactive queries, low latency queries. It's a daemon, it's a persistent server that processes SQL, and then it has in-memory caching, and it's distributed in-memory cache, builds on the Hive engine's existing sophisticated SQL capabilities, and is a long running process. So it runs, it's always on, and it can receive the queries, caches the queries, and also exposes open interfaces that can be used, composable interfaces that can be used, one of which is Spark. These extensible interfaces have the ability to have Spark read data out of LLAP, and then the added benefit here is that if you hit LLAP and you're trying to hit, let's say, data that's sitting in Hive, then Ranger has a first-class integration with the Hive LLAP piece, so you can enforce all of your security policies via that context. So Spark will receive the client-side mechanisms over there will receive the filtered data, masked data, as you've set up your policies on the other end. And this mechanism of LLAP can also go to what we call HCFS, any Hadoop-compatible file systems, which includes all of the items that you see down there. So your storage could be not only HDFS, but it could also be S3s or WASP, which is the Microsoft equivalent of S3, and Isilon if you're using EMC. So all of these LLAP can work on top of all of these, and then because of the fact that you're hitting LLAP via Spark, all of that security policy constructs and the security policies that are available will seamlessly translate over to this context. Okay. So let's do a little bit of a double click into this to see how this works. So the key idea here is that we get column level security and row level security. So you get fine grained permissioning at the column level, and you can get dynamic policies via Ranger. And the dynamic policies help you, for example, avoid different views. Let's say you want to create different views of the same data for different folks. You right now, without this feature, you're going to have to build different views and have build authorizations around those views and make sure that they are getting invoked in the right context. Ranger provides you the construct to say you define a little piece of SQL, Hive SQL, that is attached to a policy. Every time that particular user tries to access the resource in question, those policies get applied seamlessly. So depending on who you are, you get different views of the data, and we'll see an example of how that works in the demo. So the internals of how this works, so Spark SQL first will go get the splits from Hive server, and then the authorization will return, will modify the query and insert some UDFs, et cetera. And that modified query plan will now, Spark will now hit LLAP server to get that data back based on the modified query. So because the Ranger authorizes invoking the first step and the query modification happens there, you are guaranteed that your security is going to be enforced in this context. So that's how this kind of setup is giving us that added benefit of security. Okay, so just to kind of make this real, let's take this use case. We have this table here, has a bunch of sensitive data. For example, there's names, medical record numbers, date of births, insurance policy IDs, national IDs, which could be your social security numbers or your German Schufa numbers or your Chinese national IDs, Canadian SIN IDs, whatever those may be, credit card numbers, et cetera. And there are two different users. You're trying to hit this from different contexts. There's a user called Joe who's sitting in our enterprise. He's based out of the US. He belongs to the US users group, and he's a member of the analyst group as a function within your company. And you have Ivana, who's an EU employee. She's in the HR group, and then she's trying to hit the same table. And then they're running these queries. On Joe's side, he's trying to run this query to get a feel for what the distribution, for example, by country is, or maybe he's trying to get to some policy level aggregation. So he's trying to run that SQL that you see down there on the left. And then on the right here, Ivana's trying to hit the same table, but she's trying to get different data out of the same table. Now, the Ranger policy enforcement here has machinery in place to say the query can be rewritten based on the dynamic Ranger policies, and you can apply the filters based on HiveQL predicates that get tagged on. So dynamically, we will insert that additional filtering behind the scenes so you don't have to create separate views for these folks. You have the same table access and you do the same select star, they get served different set of rows depending on what they're authorized to see. So it's a very powerful construct. And then on top of that, you can also serve out masked versions of the column. So in this case, for example, Joe as an analyst cannot see some of the sensitive data, so he needs to be shown masked or anonymized or pseudonymized versions of the data, while Ivana, who is sitting in HR, needs to be able to see the original data in the clear. So we'll show how this can all be affected. So the net effect of this whole path of going via Spark SQL through Hive LLAP is that you get different views on the same table when you're running the similar query. So you'll see that the rows get filtered, the green rows showing the US-based data and the US customer data, and the orange row showing the EU-based data, because Ivana is only authorized to see EU data, Joe is only authorized to see the US-based data. So you'll see this, how this can be done seamlessly behind the scenes. Okay, so let's maybe very quickly run through the demo. This is Ranger. I will get to this in a minute. So here's a Zeppelin notebook. Let me go back. I need to get out of here. Okay. All right, so here's a Zeppelin notebook which shows some of these in action. So we have Joe, who's an analyst in this firm. He's trying to figure out where, what is the obesity index across the zip codes in the US. He's trying to run some simple analytics here, trying to aggregate and figure out what the distribution is around different zip codes. So he runs that, and he gets served that chart that you see here, which you saw there, rather. I guess I have a connectivity issue. And then the more interesting part is down here. So Joe, we know, has restrictions on what kind of data he can see. So when you run this query, there are some masking policies that need to be applied. And even though he's hitting this table, he needs to be able to be, the query needs to return results that show transform data. In this case, what we are showing is certain sensitive data. So for example, street addresses, which are considered also part of PII, those are redacted completely. The ages are randomized. You don't want to reveal the actual age of your customers here. The passwords are hashed. Your national IDs are masked here, showing only the last 4 digits, the last 4 of your SSN, for example. The credit card numbers are masked to show only the first 4, and then your medical record numbers are nullified. There's also some other sophisticated policies that you can write here, which say, for example, the analysts need to be able to preserve the year of birth of the customer so that they can run some demographic segmentation, but they are not authorized to see the actual birth date, which means you have to kind of mask or redact them in some way, or kind of put a default value, which is like 0101. So we want to be able to enable the analyst to do this analytics while not inhibiting them from being able to get to that demographic segmentation part. So as these events happen in Ranger, you can also see that all those queries that were run, every one of those events as to what did Joe try to hit, and then you can see that he is actually going through Hive and what column he accessed, what was the operation, etc. We get very detailed audits. So from a security and governance perspective, we can actually see that you have a built-in audit trail even though you're hitting this from Spark. Similarly, we can go to Ivana. I'm not going to run this. It takes a while to run this, these queries. So you'll see that we've got authorizations in play. So this is just a plain Hive path. So maybe this HR analyst is not as sophisticated. She doesn't want to use path. The use part, she's using just JDBC to Hive. And because we have Hive LLAP, the same policies will seamlessly get applied behind the scenes. And you'll see that different data is appearing here. One is that she's trying to access US customers' data, and she's getting blocked. And on the right here, even though she does a select star on a table that has data from customers from all over the world, she's only served the European data that she's authorized to see. And you'll see corresponding to this when you execute this query that there is masking and row filtering. So you'll see some events corresponding to that other persona here in the back. I'd already pre-run this before the talk. So you'll see that some of these row filtering policies that we had set up would get applied. Setting up these policies in Ranger are very, very straightforward. This is not a Ranger talk, so I'll just not spend a lot of time on it. I'll just show you one example policy to see how easy it is to say, let's take this one here. You pick your database table and column. You pick the group that you want to allow or deny access. And then in this case, since we're doing masking, we want to pick a masking option. So there are some available out of the box. And if you don't like what we have, we also allow you to have your own custom options, which means you can drop in any Hive UDF that returns the same type as the column. And the data will be masked with that context. Row filtering. Very simple to write. So instead of managing multiple views for these customers, remember Joe and Ivana were trying to hit the same worldwide customers table, and they need to be shown different piece of data. So we insert these predicates here. You see a policy condition that says for all the US employees, and by the way, this US employee list is coming from your LDAP or AD, so it's synchronized. Ranger has a way to synchronize these with LDAP or AD, so you will be able to now insert and filter these rows dynamically based on this context. So you're saying whenever a US employee tries to access this table and they issue any query, only show those customers whose country of residency is US. And the second one here is actually a little bit more sophisticated condition, which says, I have a reference table which has a list of countries in EU, and then we can now go look it up and say, filter these dynamically to say, only allow those countries in the EU. So tomorrow if France decides to exit EU, we just change that reference data and it'll get applied seamlessly without having to do any kind of additional manipulation. And you'll see that here in place. So when Joe ran it, you saw that the data was masked. When Ivana ran this, all this data is in the clear. So you can actually see that. She can see the credit card numbers, she can see the national IDs, she can see the birthdays in the clear. So in the same context, even if you're using different engines and for different personas, you can now apply all of these policies, and you can apply this consistently independent of the engine. You can, whether you're just using JDBC going direct to Hive or using Hive LLAP via Spark SQL, we get the same answer. And that ensures that you can have consistent policy enforcement across all of these independent of which engine you're using to run this. This is probably the, I would say, the complete picture that Vinay mentioned in terms of our security stack for, let me see here, I think I need to get to this. All right. For Spark, and let me go back to our presentation from where we left off here. All right, so key benefits, I'll have highlight a couple of these. So we have shared access control policy between Spark SQL and Hive. The benefit to this is that independent of which way you're getting to this, you're getting the same policies applied. So you now have one way to define it and multiple ways, multiple contexts in which it can enforce consistently. Second piece is the auditing capabilities. You saw that every single time anybody tried to access this, you're getting all of those audits back in Ranger. So now you have a non-reputable source for your auditors to show how your people are getting to this data and what kind of access is happening and what are the patterns around that. In the case of resource management, each of these can be put into a separate queue. So this Ranger can also authorize yarn queues, so you have an additional layer of control there in terms of who can submit jobs to these different queues. And then the last piece here is that we have a minimum transition cost because now, independent of all of these contexts, we can now have consistent enforcement with these engines. So then you don't have any way, you don't have to do additional work in terms of being able to do query rewrites, et cetera, because of the seamless enforcement behind the scenes. There's a couple of blogs out here that you can look at to understand how this works, and we go into a lot of detail with some use cases in these blogs. So I'll switch it back over to Vinay here, who will cover the rest of the what's ahead for Spark security.
So in terms of what new features in security you can expect in future. So one of the key items we have seen is Spark and Atlas integration. And the reason for doing this, if you're creating an entity, if you're doing Spark ETL, you should be able to create a table through Spark ETL, and you should be able to get the governance of the lineage with that, so your data stewards can go follow how this table was created, et cetera. So that's why we'll do the Spark and Atlas integration. As you can see, Livy was a way to launch Spark Job, and in Hadoop ecosystem, Knox is the authentication API for anything that does with REST API or over HTTP. So Livy and Knox will integrate. Zeppelin will also do SSO authentication. So if you attended the previous Zeppelin talk, you may have wondered why I even want to configure LDAP in Zeppelin, and we will avoid all that with Zeppelin SSO integration. Zeppelin will also integrate with Ranger, and wherever else passwords are stored, they will all integrate with Hadoop Credential API. If you have a lot of questions or any questions, I will request that maybe we can take questions outside so our friend here can wrap up early. And yep.
Thank you.
Thank you.